In this section, we're going to explain elemental loop Fapratox analysis. Fapratox is abbreviation of functional annotation of prokaryotic taxa. Fapratox manually constructed a database of species classification and functional annotation based on the literature, which is a Python script was written to connect to the OTU classification table and the database. As long as we use the 16S based OTU classification table and use the Python script, we can obtain the functional annotation prediction of the microbial community. Basically, Fapratox was published in 2016 and has been cited more than 14,000 times. It is well annotated in terms of focusing on the recycling function of elements and has many applications in the environment and agricultural field. It was updated its version. Fapratox does not have an online version and require local scripts, databases, and dependencies, and prepare OTU table with species annotation as input. It is recommended to use ImageGP online version to complete the analysis with one click, and we can use Linux server as well. Basically, Fapratox is more suitable for functional annotation and prediction of biogeochemical cycle processes, especially cycle of carbon, hydrogen, nitrogen, phosphorus, sulfur, and other elements in environmental samples such as ocean and lakes. Because it is based on published and verified literature on cultivable bacteria, its prediction accuracy is good, but its coverage is low. You can see here, this is the taxa and this is the function, denitrification, nitrification, and fermentation. What are the results of Fapratox result look like? It is very similar to the OTU table and KO table, and it is a matrix corresponding to functional description and samples. And the application of Fapratox result, we can use heat map of functional abundance corresponding to sample group, and we can draw a bubble diagram of correlation between environmental factor and functions. We can use this proportion of predicted function by using predicting bacterial flora based on Fapratox database, which is published in PNAS, the study, which is uniqueness of the human skin microbiome in mammalian phylogenetic symbiosis. And excavating the differences in bacteria related to nitrogen function, you can see here, we draw here, and this graph, this picture is showing the differential bacteria related to reported nitrogen cycle fictions. And this is among the 9 most abundant pathway enriched in indica rice. 6 were related to nitrogen. And method 1 is ImageGP. We can just open ImageGP and go to the Fapratox section. And here we have to paste OTU tab text and taxonomy text, which is located in our working directory, and then we will click and submit, and then we get our Fapratox output files. And method 2 is local Linux is under CHIME2, and for Windows user we can just switch our terminal from Git Bash to Windows Subsystem Linux terminal, and then we can get run by one, we can execute the code. And if you are using ImageGP, we have to download the Fapratox from this link. Just click it and it will take you to the website of Fapratox. And if you are using Linux server, then you just execute this command. It will automatically download it. And then we can activate Conda environment, which activates CHIME2. And then we execute all this command turn by turn. And we create input OTU table by executing this command, and we will generate species annotation and then specify input file, species annotation, and output file, and then we can execute this code. And when we generate the files by using Linux server or by using ImageGP, we will get such kind of OU2 function, annotation list, function contain OUT list, Fapratox report function, and OUT function with or without matrix. Then we're gonna analyze all these files by using STEM software, and we get such kind of realization. Now let's have a look one by one to both this method, ImageGP and Linux server. Now we have ImageGP page open here in our browser. We just go to the section of Fapratox, click over here, and then it shows us that we need here OTU abundance table, and here we need taxonomy annotation of OTUs. So let's go back to our working directory, and under GG we have our OTU tab text. Open it, copy it, and open in Excel sheet first and paste over here. Now see the format here, it is without space, so we will remove the space and delete this hash symbol from here. After that, we will copy all and paste over here. Now come to the taxonomy text and paste over here, and then just in case if it take more time, you just write your email and click plot. It will take some time to generate output files. Now you can see here download result file. Just click here and copy this folder and come back in your working directory, and you have to create here a directory with the name of FabraTalks. So the one we downloaded, we just paste here and we will unzip it. It's preferably we will just copy all this file and here and delete this, and after that we're gonna make arrangement in their name. We will just keep the name like FabraTalks report clean final, FabraTalks report clean function, FabraTalks report clean OTU, FabraTalks report clean, FabraTalks report XLS, FabraTalks, like this. We don't need this kind of numbers before that, so we will one by one rename them and delete unnecessary information from their name. Now you can see here we eventually get FabraTalks report clean, FabraTalks report, and FabraTalks report clean, FabraTalks report XLS, FabraTalks XLS. So I told you earlier we have to download the latest version of FabraTalks by using a browser. We have to copy the link. Yes, we will go to this link and we will open it in our browser. And here you will go FabraTalks included associated software, which is available here, and then download the latest version. Now copy this and bring in your FabraTalks directory. Now all these files we generated by using ImageAP. Now come back to the RStudio and we can execute the code under Linux system or Linux environment. Come over here. Now we go to the section which with the name appendix analysis under Linux. We go there straightly. Now see appendix analysis under Linux server, and we will go to the FabraTalks section. Now here we go. There is FabraTalks element cycle. First of all, we have to set our working directory, and before executing this code, we have to make sure that our terminal is not git bash. We have to switch our terminal now. Let's see here how we will do this. Now currently it's git bash. We will now execute this command under Windows subsystem for Linux. Just click here, apply, and OK. We open a new terminal. And now come here. This is our new terminal. And here we will run this code one by one. We will see here. First of all, we are going to set our working directory, which already we are in mntd EasyAmplicon. But we have to go here. We are going to create directory. Inside the result, we are going to create a folder with the name of FabraTalks. Let's execute this code. Now it shows that our file already exists there. Let's see. Now we have generated FabraTalks under Linux server, and we have generated FabraTalks file by using ImageAP. So what we're gonna do, we can visualize these files by using Stamp software. We can open Stamp here, and then we will load files. Go to our working directory, EasyAmplicon, result, and the folder which we just created under Linux. We will open this, and then we will choose Reproducible text file, and then in the next column we will upload metadata text and click OK. You can see here we will eventually get PCA. And then you can make comparison between two groups. You can see here, if you can make two groups and you will change groups from here, you can see here you have heat map plot, you have PCA plot, scatter plot we can draw, we can get extended error bar as well. So you can have multiple options of visualization if you want to use your file under STEM software. You can use two samples. Now you can see here sequence histogram, you can see bar plot, extended error bar, and multiple comparison plot, which is corrected p-value, and with a significant feature, with raw p-value, and with number of features. You can use p-value histogram, and you can configure your plot manually by adjusting all these parameters by yourself. And this is how we can visualize our files under STEM software.